also caveat this that I am by no means expert in functional programming or in Clojure, but I am intensely curious about the subject. I've been looking at Clojure the last year and a half, and just recently, probably the last 6 months, it's actually become feasible and quite easy to get started with Clojure. And that's through the help of Lineagen, which we'll show in a few minutes. So should you guys fall behind, I put everything on my GitHub repo called Clojure Intro. It's just a little markdown outline of everything we're going to go over. And you can reproduce everything that we do today on your own later as well, or you can follow along as we go. I'm using Mac, so if you're using Windows and want to get started, your install process is going to be different. I'm not fully aware of how you're going to do that. I know you can do Lineagen on Windows. I don't use Windows, so without any further ado, how will we get started with Clojure? If you're on a Mac, install Homebrew. You can copy paste my Ruby, or you can go to the Homebrew link there and they'll let you copy paste their Ruby link. Install Lineagen, just brew install Lineagen. Lineagen is this really awesome build tool for Clojure. It gives you a lot of functionality. The biggest thing will be the REPL, which is a read, evaluate, print loop. And that's what we'll be working off of. Switch over to
Sean, sorry to interrupt. Can you be a little bit louder?
Yeah.
We have folks commenting saying they couldn't hear.
Okay. Yeah, let me know if I need to speak up. And hopefully it won't sound like I'm shouting in here. So we get started. Like I said, Lineagen does a lot of things. It's got the REPL. We can just say lean REPL. It'll start up a JVM for us, give us a little user prompt, and it's ready to start taking evaluation. It also does things, and we'll show at the end. You can create a brand new project skeleton and just say lean new app, my app, and it'll create a new application for you. There's a lot of templates out there that people have been creating, and it'll create a project skeleton based on their template. So that's pretty cool. You can use lean to then run your project. If you're in your project directory, just say lean run. It will fire up the JVM. It'll look for a main entry point and then kick off your program. So Clojure is a Lisp, and we'll start off with the REPL of understanding what a Lisp is, right? So, Lisps are list-based programming. The data is the code. So you can open a parentheses and you can put a simple function in there. This function will just be plus. We'll say 1, 2, and we should, expect the result of 3, right? And you'll notice here that we're kind of using a prefix notation versus infix. So we're not saying 1 plus 2, and this makes things easy. Like if we want to add multiple numbers up, we could just say, 1, 2, 3, 4, 5. We don't have to say 1 plus 2 plus 3 plus 4 plus 5. And this allows you to chain things, which is the kind of the cool part of functional programming, is you can chain small functions together to get big results. If we wanted to sum all the numbers from 1 to 10, it would be kind of long to type out all of those numbers. So we could use a function like range and say 10. It will give us a list of all the numbers from 0 through 9. We said we wanted to have all the numbers from 0 to 100 that were divisible by 5. We could do a step in there, right? And you've probably seen some computer science problems where they say, hey, how would you sum up all the numbers from 0 to 1,000 that are divisible by 3, plus all the numbers that are divisible by 5? And you can, by just using a couple of functions like this, you can chain those together and do that quite easily. If you think about how you'd have to do that in an imperative language like Java, looping through numbers and taking numbers, and it's a lot more work. So let's look at some other functions. Let's say, so we already see we have range, right? And we want to do, before we did this plus symbol, right? We could do something like apply plus to a range of 10. Add those up. Let's say we can also do a filter. Let's say we want all the even numbers, right? So instead of just doing range 0, 100, 2 to get all the even numbers, we could do something like a filter. And we could use a predicate. We could say even. You'll see that they use things, a common convention in Clojure is if you're returning a true or false value to add question mark to the end of your function name. So we say filter, even, range 101, because it's exclusive on the upper limit. You get the same thing. So that's just kind of how the functions work. Next, we'll kind of talk about collections. And there's 3 main types of collections in Clojure. You start off with a list, and the list is something wrapped in parentheses. Lists are evaluated specially. So when you it expects the first function to be the first parameter to be a function, right? To get around that, you can use the quote and say 1, 2, 3, 4, 5. Produce a list. If I didn't have that quote and I just said 1, 2, 3, 4, it would say, oh, hey, 1 is not a function. I'm looking for a function. I can't cast that to a function. You can do some neat things with lists. So let's define nums, range 10. And then we can just look at nums. There it is, 0 through 9. We can do some cool little functions on a list. We can say, well, give me the first num. And say, give me the last. Say, give me next, which gives me everything after the first, right? These are kind of idiomatic functional programming constructs. We could do something a little bit more fluent and say, hey, I want to take the first 2 nums. Take 2 nums. Give me 0, 1. Maybe I want to apply a function to that list. So I could do something like, say, map inc. I want to increment. And now, instead of 0 through 9, it's 1 through 10. But you'll see that nums hasn't changed. And that's kind of the important concept with Clojure is that all these data types are immutable. They don't change, right? I'm just taking data in and I'm operating on it and I'm returning a brand new result. Let's say I wanted to add an item to a list. I could use conj. And I could say 1, 2, 3. And we'll add 4 to it. And the interesting thing you'll notice here is 4 goes on the beginning. So with the list, everything's always added to the front, and it's important to remember that. If you need a collection type where things are added to the end, then you'd like to use a vector, and that's the next data type we're going to talk about. So vectors are similar to lists. They're just defined with brackets instead of parentheses, and they index access to them is in constant time, so you can access any member in there in constant time. Things are added to the end. So if you need to do operations like you ever need to reverse a collection, a vector would be better than a list since things are already added to the end. So let's create a vector. We can say find a vec. It's going to look like this inside of brackets instead of parentheses. If we wanted to add an item, we still use conj. Conj works on all the sequence types. But you'll see at this time, it's now added to the end instead of the beginning. Accessing items in there, there's multiple ways you can do that. We can do nth. So we'll say nth 1, 2, 3, 4. And say we want to get the second item, so we'll say 1. Gives us 2. We could use get. It's going to do something very similar. Gives 2. Or we can use the vector as a function of itself. So, all right, and say 1. So again, it kind of gets back to the idea that data is the code. You can pass around your data structures and they can be functions on themselves. Those all return the same thing, but they behave differently should there be exception conditions. So let's bring those back up and say nth, and let's pass in 4 instead of 1. We get an index out of range, right? If we do get, it'll return nil. If we use just the vector as the function, we'll get index out of bounds. So how those react to asking for selectors without that don't exist is going to be different. The other thing cool about a vector is they can be used as a stack, and they've already defined some functions to. You could access a vector using, you could add items using cons. You could use the indexing to get to it. You could say first, last, but it's not really the convention when you're treating it as a stack. You want to actually use the typical peek, pop. Still use conj to add things to it. So we can say find a vec, find a stack.
Can I ask you a question?
Yeah.
So what's the main difference between a functional programming language versus a high-level language like Ruby or something like that?
So Ruby does have some functional concepts, right? It's a dynamic language. This is a dynamic language as well, versus something that's really statically typed like Java. It's really more about thinking of how you structure your programs, right? You think of, it's more like the Unix concept of having small little functions that do one little thing, right? And then you can take those functions, they are idempotent, right? Every time you call that function, you're going to get the exact same result back, right? And so knowing that there's no side effects when you call that function, that's the other big thing, is that you can chain them together, right? So I think it's just the way you structure your code differently. I think you can use a lot less code to write some of the same things because you don't need all of the boilerplate of creating classes and methods and defining things as objects. One of the key concepts, and the reason I really got interested in functional programming and Clojure in particular was I ran across a video on InfoQ with Rich Hickey. And Rich Hickey, actually someone joined as Rich Hickey today on the conference. You'll see, I thought that's kind of funny. But he's the creator of Clojure, and I saw his video, and he was just giving us an overview of, hey, why are we doing things the same way we've been doing the last 20 years with object-oriented programming? And I really kind of opened my eyes to, I'd never been exposed to Lisp, I'd never been exposed to any of the functional languages, and his talk really moved me, kind of woke me up to, have some of that initial curiosity I had, 30 years ago when I started playing with computers. And I was like, wow, this is just, it makes a lot of sense, it's really cool. It took me a while to wrap my head around how things work. And like I said, I'm by no means an expert in this, I'm still very much a student, but watching his video on state, and that was what it was about. It was like, state and changing state is the root of all evil in most of our, programs, right? You come into, like our example, code I work on is part of EBP, eBay Fire Protection. You'll come into one method in a class and you'll say, oh, hey, I'm going to go call this other method on this other class and pass in this object. Well, is that object being changed in that other method? I don't know. Is that object then being passed to another, method that's maybe changing it? No, I don't know. And there'll be a comment that says, oh, don't change this object here. We're going to change it over in another function, right? And that kind of madness, it's easily just pervades typical object-oriented programming, right? And it's not because that's a symptom of OO programming. OO programming solves a lot of great needs. It's just it's easy to get yourself in trouble, right? When you look at something like Clojure, any kind of side effect is very explicit. You have to explicitly say that you're going to be creating some side effect. Immutability is the default. Nothing changes. As you saw here with some of these lists, as I was, adding an item to a list, I really just returned a new list. That original list is still there. Nothing changed. And it allows you to be very efficient too. When you think, if I add a new list, I just create it, and next is a reference to my previous list, right? So when I said, hey, let's add 4 to the list 1, 2, 3, well, it gives me fourth 1, 2, 3. Well, if I say it's called next on there, we'll do that here. What was my nums? There's 1 through 10. Let's say I say con nums, and we'll add 11. All right, and now let's say let's actually do this. Let's say next. Right, and it returns that original list. And we know it's original because when we say equals next conj 11, is that equal to nums? Parity, did I miss one of those up? Equals next. I know what?
One of those right parentheses up.
Oh, I have the wrong.
The 2 parentheses after 11.
After 11? Okay. There we go. So you can see equal next, when we do that conj of nums 11 to nums, it's the same original list. Right? And so that allows you to create these really efficient data structures where you're not, making a copy of the original. You're just making, a new list with a pointer to the old list. The same with the vectors. When you do conj with vectors, you can, you keep the original. It's just a pointer to the new. So it allows you to manipulate lots of data. And I think that was the original point I was going to make 3 minutes ago. Was there's a saying that you'd rather have 100 functions that operate on one data structure than 10 functions operating on 10 data structures, right? And I thought about that for a while, and I was like, it makes a lot of sense where, everything that we do is based around manipulating data, right? We're really data processors, and having a single canonical data structure that we know well, and writing lots of functions that manipulate and project different representations of that data, it is a pretty interesting idea of how we could approach our problems versus, maybe modeling things out as, objects that things happen to versus data and snapshots of changes of that data over time. So we were doing the stack, right? We have 1, 2, 3. We could do things like peek our stack, return 3. We could do pop, our stack. Pop is just going to give us the first two items. It just takes off the last item, right? But you know, stack hasn't changed. It's still there, right? We just returned the first two items off of it. Get to add an item to it. Yep.
Dumb question. So you have a stack.
Yep.
And then you did pop a stack. You got one too.
Mhm.
What if, I don't know the exact syntax, but what kind of error would you get if you tried to modify a stack? Like what if you were to say, in Java terms like a stack equals, you know, pop a stack or something. So you're trying to assign a stack to 212. Would it throw an error?
You'd have to explicitly redefine a stack as.
So it wouldn't let you do it by default.
No, so you know, you can see here we try to add an item to it. You know, it just returns a new vector, right, of those items. We'd have to actually try to redefine a stack. I think that's right.
So that,
So you want to walk through what that means?
So what I did before here is I just redefined def a stack. We did that earlier when we created the first stack. So I just redefined it, saying that I'm going to vec is the vector function. So when I say conj a stack 5, I'm going to return a new stack with the concatenation of 5 to the original a stack. And I just want to say I want to return that explicitly as a vector. But saying that, I think I could have removed the vec function, because I think since a stack's already a vector, it would return a vector anyways. We could try that.
change to 5, 6 or something.
Yeah, since a stack's already a vector, conj will already return a vector, so I needed to meet that. That answer?
Sure.
So you have to, you explicitly redefine what that is. And then there's another construct in Clojure called an atom. If you want to store state and accumulate state, that is explicitly says that this is immutable. I haven't used atoms yet, so I can't really go into depth of how they work.
So there's nothing that enforces immutability then in Clojure. Do you really want to shoot yourself in the foot?
No, it's enforced by default, right? You have to redefine. You have to redefine whatever your symbol is, right? You're not, if it was, mutable by default, when we did the conj, you would expect that 1, 2, 3, 4 to be a stack, right?
Okay.
But it's not. It didn't change it. It just returned a new instance of it. I think the last data structure or collection type I was going to talk about was maps. And maps are just defined by braces. So say map, and they are a key value pair, just like any typical map. So take use a set of keywords. So we'll say A1, B2, C3. And we get a couple of maps. There's some cool functions with maps. So say that you want to do something like zip together a set of keys with values and create a map out of it. You could use zip map. You could say A, B, C. And we say 1, 2, 3. And create that map. Order, since it is a map, order's not guaranteed. I think the last thing that I was going to show, let's see, is let's exit the REPL. CD out of here. Okay, so if we want to create a new Clojure application, so we've been working at a REPL, but it's not really been, it's not an actual application. You just use lean again. You say lean new app, and we'll call this one. I already have a my app in there, so we'll call my new app. And he'll use the app template that's in there. We can just say, look in there, my. Creates a README, a doc, a source project, source, tests, and then you see this project Clojure. So say this is again an example of how the code is data and data is code. You can see that the project definition for our Clojure project is just a list with some map items in it and some vectors, right? So we've got define project is the function. It's my new app is the name. Version. We've got a description, URL, license, dependencies. You can see here we're using version 1.5.1. The nice thing in there, we could add something like, if we're doing a web app, we could add pickup. Pickup's a really cool Clojure library, right? That they've created a DSL where you use things like, you create vectors and maps of what your HTML structure is going to look like. So I could say HTML is a function, it'll create an HTML page for me. I could then just put in things like divs, do colon div, colon span, whatever, and I can just build up a data structure that represents what my HTML page is. I can write a function around that and pass in another data structure to then populate it, right? And you come up with some really cool templating.
Like the Ruby Rails.
Yeah, very, very similar. All you're really doing is you're taking one data structure and applying data to it and outputting, HTML template. So you can see here it says main is my new app core. So if we just go in here and we'll say source, my new app core. Brings up this guy, just a hello world. If we quit and we say now lean run, you should see hello world. It exits immediately for us. And that's it. That's pretty much my demonstration. Any questions on?
We can go back to the
Yeah. You want? Which one do you want to see? You want to see the project one or the?
The leader has unmuted your line.
This one here?
Yeah, so can you explain what is the source of these data? So it sounds like every line there is a map entry, right?
Yep.
Description, URL, license.
Right.
You have the command names, you're supposed to include the lines that's the same.
Yeah.
And what about the first item, that project, space?
So def project is a function. So it says I'm going to define a project. He's going to expect as his parameters a name. So that'd be my new app, version, and then a map of attributes for that project: description, URL, license, dependencies, and then an entry point. Main is the entry point for this application. So when we do things like lean run, it looks through this project .clj file and says, oh, we look for the main keyword. I know I need to go to mynewapp.core, and that's going to be the entry point for the JVM. It'll also look in there and see through dependencies. Right here we just have Clojure, but like I said, if we added hiccup or we added ring or some other, Lean uses Maven for dependency management, and there's two main repositories by default. You have Clojures, which are all the shared Clojure libraries, and then you have Maven Central. So anything that's out in Maven Central, you could add a dependency to, and you could use to interact with any Java library, Scala, or any JVM library which interact with. And then there's a whole set of community-initiated open source libraries out there in Clojures.
What about the folder structure that maybe has explanation? Does it use it?
It sort of uses it. You'll see in here that we have that. So you'll see we have a source, we have a test that has our test in it. Those aren't hard and fast rules. Any template can define any structure they want. I'm looking at a framework right now. It's called Pedestal, and it's the full stack web Clojure on the back end, Clojure script on the front end environment, and they use a different folder structure for their app. So it's pretty much how we want to define that folder structure. This seems like to be the popular convention. Go with source and test, and you put your test files in there.
So when you did lean run,
Mm-hmm.
did it run a Maven goal and then compiled it and then ran it?
Kind of. When I do lean run, since I'm in this directory, the first thing it does is it looks for projects.clj. It'll look through the dependencies and see if all the dependencies are there. Like, let's see. We'll add a dependency. Just so you can kind of see. So we'll add this guy. Now, if we say lean depths, right? You'll come in there and look. And you say, oh, we got to get hiccup from Clojures. If I didn't run lean depths, if I just did lean run, I think it runs lean depths first anyways for you. But explicitly, if you want to see what it does, then just put it in there.
So it's Java plus Maven.
Yeah, they decided to use. I think it's kind of a good idea too to use the repository aspect of Maven to give you a centralized place to put dependencies, right? So that I don't have to worry about the version you have on your machine versus my machine for hiccup, right? I know I can just say, hey, I want hiccup version 1.0.3, and it's going to go out to a shared repository. Everybody's using it.
So Clojure can use Java and Java can use Clojure.
Yeah. So everything gets compiled as a jar. So
Clojure is able to use the Java classes in the jar, and a Java program can also call the classes created by Clojure.
Can you do in the REPL, is it possible to do an example of calling something from the standard JK library, like something simple like system.out.println?
let's say get is that right?
Isn't it get PNP?
Ah. there we go. Like, that's just calling the,
So you replace the dots with slashes? So the system/out/frontline?
right.
But then you don't
The
use
leader has muted your line. To unmute your line, press
No,
pound
so
6.
like I said, the first thing is going to be the function we want to call. So we know that, we're saying uppercase system, that's going to be from Java's core system library, right? Slash is going to be, okay, what function do we want to call inside of there? So we're just using that as namespace escaping, kind of similar to the dot.
And then in Java, if you wanted to call Clojure, that's possible. So we just treat it as a class then. It's
Yeah,
a new my Clojure class. And
Yeah,
then,
you say, yeah.
Then my Clojure dot do something, and it would go into Clojure and
Call into functions and say you'd use the Java syntax, right?
In what situation would you prefer to instead of Java?
That's a good question. Do I see anything here in my work at eBay where I could use it? I think with some data processing things that we do on the back end, I could see some pretty interesting libraries created there that, like we deal with claims, being able to, iterate and process claims and try to aggregate results out of, hey, how many, claims per day that are I'm not received and we receive, doing things like that. I could see using it for that. I could see, for smaller shops that are doing startups and stuff, they're trying to choose what kind of web app they want to create. They could use something in Node.js, or they could go something here in Clojure. I think it would be just as usable there. You can, I posted something down in Heroku with Clojure. They just like Node, they also support Clojure. So,
And would you say that there is at least performance and productivity or both?
I think expressibility. It's so if you have something like, I think you'd write a lot less code with the Clojure than trying to write it in Java in certain aspects. Like just like the example I said earlier about the computer science, there'd be a question of, hey, add up all the numbers from 0 to 1,000 that are, divisible by 3 and 5, right? And you say, okay, I want to write that out in Java. How many lines is it going to be versus the, one line of Clojure that you could do it in?
So does this support synchronization? Because looks like this is kind of pretty good for code that intensively uses the data structures. But like for most of the things that we do, a lot of these data structures require synchronous access. Can we do that in Clojure?
Well, I think it's a different way that you have to think about how you structure a program, right? And so wanting to access the same piece of data and mutate it by multiple people, that's always going to be, you have to lock that data down before you change it so that other people are reading it are not going to get a dirty read, right? So you have to really think, is there other way that I could structure my program so I don't need to do that, right? Like the way, not to get on a tangent, but the way we think about data, right, and databases, and it seems funny to me how we work with the database. So imagine if that database was worked the same way as logs, or imagine if logs worked the same way as your database, right? Where the last write that you did overwrote the previous. So you only get to see the last write. And so I go to look at my log on my web server, and oh hey, last was this get on this resource and it returned 2 OK. Oh, I don't know what happened before that because every time I write to a log, I overwrite the last previous entry, right? Versus if we treated a database like a log, where 30 years ago, storage was super expensive, right? Now storage is cheap. So when I go and create a new entry, say I'm going to create a new claim in the database, and the status of that is open. It's the first state for a claim, and a few minutes later, now it's going to move to escalated. And so instead of going and updating the column for state from update it from open to escalated, maybe I add another entry in there, another row that says, okay, at the time, this timestamp the state was open, now at this timestamp it's escalated, at this timestamp it's closed. I can always go in there and replay the whole history of that claim, based on snapshots of time. At this point in time, this is the latest state of this object versus, the latest state of this object is the only state, the only history that I know of this data. But it's a different way of thinking of how you structure an application and write it. With this,
You shouldn't really need to synchronize because the data never changes. The object that if two processes are dealing with the same object, two threads are dealing with the same object, there's no issue about synchronization because the data itself never changes. Each one of them will create new copies of modified versions of that state. So that's one of the reasons why you see maps here used so frequently, and you can think about how MapReduce works in Google. It's essentially the same concept. You're breaking one big problem into a lot of little problems to let each process do its own thing, and then just combine the results. You don't really have objects manipulating the same objects.
But what if a piece of code is accessing an external object that can change, and you want that piece of code block to be synchronized?
Yeah, so I mean, from my understanding, because this is sitting on top of the JVM, when you have those types of instances, maybe that's not when you use Clojure. That may be a case where you say, I need to use a language that treats mutability a certain way. I'm going to use Java for that part of it. You call that library from Clojure, and you just assume that once you get the data back, now it's immutable. You can play with it.
and I think they do have support for mutexes from this, so that you can put a mutex on an object and then access it.
Even you can have a block synchronization in Java when you access Clojure libraries. So that will essentially do the same thing. Like you don't need to have those implemented using Clojure.
And Clojure supports multi-threading. So it was basically a new compiler written using Java.
Pretty much. I mean, it's a compiler that compiles down to bytecode. Alana actually brought up a really neat example. I'm going to try to do this later and see what it is, but talking about, again, back to that computer science problem and writing the Clojure out to do it, and then kind of looking at the decompiling the class and seeing what the Java looks like that it created to do that would be an interesting experiment just to see. Because then at the end of the day, that's what it is. All this stuff gets compiled out of Java.
Bytecode.
Yeah, it's actually not. I think it's actually Java classes that then compile to bytecode. This creates Java classes, and then
So from CLB you go to Java, from Java you go to class.
I think that's the way.
I thought it
Leader
went
has
directly
unmuted
to
your
that
line.
class. I thought it went directly to that class.
I could look and see, but I think there's supposed to be Java classes under there.
Does that mean you can even extend the Clojure classes in Java?
That'd be interesting.
Right.
I think we can.
But I mean,
Sorry to interrupt. Let me give a chance for the folks on the phone to ask any questions. Folks on the phone, do you guys have any questions?
So what's the use of this? So what
Going
the
once,
right place is very
going twice. Okay, I'll take that as a no.
No.
I haven't heard from
I've
anybody.
read some of that.
Remember what the list processing languages were called in the first place. Because with the same amount of compute, you could process hundreds of thousands of times as much data. And that's why all the data ecosystems were written in those 40 years ago. But because with a limited amount of processing power, you could afford to process tremendous amounts more data. And that's why you would use something like Clojure to say, this is the type of work we're trying to do. Well, then this is the type of language you would pick to do it. When you get into the immutability of objects, you get a lot of safety working with huge
Say for
files.
do concurrent programming then. And I was reading something that's why like a lot of big Wall Street type companies use these sort of functional languages, is it makes concurrency very safe for them, and they want to do lots of transactions for a microsecond to get that last little penny. So,
It's taken generations of computer science to get the directive languages to get to the abilities that the functional languages have.
there's an old saying, I mean, I have a friend who's an old Lisp programmer, and, you know, he said there's nothing new in computer science like the last 30 years, and you just keep borrowing ideas from Lisp and, you know, putting in other languages and calling it new and revolutionary, but it's really not.
Yeah, and then hopefully this just kind of sparks some curiosity in you guys that again need to, you know, maybe rethink the way you write Java, right? The methods that you write, trying to make them more, you know, isolated and not
There's a site called For Clojure
mm-hmm.
that I found very useful as I was going through this stuff. Just a little practice programs, very simple little problems that you
So
solve.
that's like the columns or something?
Yeah. And really, the nice thing about this site was that they don't give you the answer until you solve the problem. But then you can see how other people solve the problem. And that was actually, I mean, it was very helpful for me learning. Because I would spend, you know, an hour trying to write 4 lines of code that would solve a problem. And then I find that there's a 2-word statement that does that in Clojure. It's like, oh,
When
okay.
I tried to learn, when I was playing around with Clojure, I think it's called the cones. You know, where you have a program running and then you're modifying it, but it's running at the same time you're modifying it. And as you go through it, I mean, you're correcting each line to make it compile and work, and then it goes to the next line, which you need to figure out.
Is there a nice editor for Clojure?
Yeah, you can use any editor you want. There's Eclipse plugins, there's IntelliJ, Sublime Text.
There's one built specifically for Clojure,
Yeah.
which is Lighttable.
Yeah.
Lighttable is very nice because it basically has the REPL running there with you. So as you're changing the lines of code, it shows you the output of the program on the side. Very cool.
Andy wrote all of that in Clojure. Now he actually rewrote it in Clojure script. It's Chris Granger. It was a Kickstarter project that now Y Combinator company. So very cool.
So is Clojure script or something like those scripting languages, is that the future of JavaScript?
Well, so what Clojure script has done is it allows you to write Clojure just like Clojure, but it uses Google Clojure with the S to compile your Clojure into JavaScript, and it supports full.
Because there is no engine for Clojure scripts on any of the browsers.
No, so it compiles it to JavaScript, but it's V8, you know, and it does full advanced mode for Google Clojure. So when you do the minification, it actually goes in and drops out unused code and stuff. So it gives you pretty highly optimized JavaScript writing Clojure. So you can write Clojure in the back end, Clojure script for your front end if you want, and never leave the language.
Well, we are running almost out of time, so let me take this opportunity to thank Sean for taking his time, and thank you guys. Hope this was very helpful. Also, before we leave for the Tech Update series, we're looking for presenters. So if you play around with your, with any of your favorite technologies, and if you want to present it, share it with your fellow developers, please let me know. Thank you, guys.
Thanks, Sean.
Thanks, Sean. Sure.